Hey guys, welcome to my channel. In this video, I'm going to be working over different types of problems, and this is pretty much a common assessment review. So for the first problem, we have a quadratic, and it says that we need to factor. First thing that I notice is that the value of a, my leading coefficient, is not 1, so because of that, I'm going to do the super Xbox. I want to do the super Xbox. By the way, before I even go over the problems, you're more than welcome to pause the video and try them yourself and see if you can get them right. So after I do the super Xbox, I'm going to multiply the first term with the value of c, or a times c, the leading coefficient with the constant. So 2 times negative 6 is negative 6. 2 times negative 3 is negative 6. And then I'm going to write down the value of my middle term, which is negative x. It's actually a negative 1, so I'm going to write down negative 1. And now I need to find two numbers that when I multiply them give me negative 6, but when I add them give me negative 1. But before I do that, I'm just going to set up my box here. I'm going to write down the first term on the first box and the last term on the last box, which is negative 3x. So as I'm thinking about it, I think that negative 3 and positive 2 actually are the magical numbers. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So I'm going to write them here. Negative 3x and 2x. And now I need to ask myself, well, what is the greatest common factor? What is the greatest common factor between 2 and 2? Hopefully you answer 2. And then how many power of x's as an x squared and an x half? And that is 1x. And then I ask myself, what times 2x gives me 2x squared? That is just x. And then x times what? X times what gives me negative 3x. And the answer is negative 3. And lastly, I ask myself, well, what times 2x? What times 2x gives me 2x? And the answer for that is positive 1. And now I check, well, x times 2x is 2x squared, 1 times 2x is 2x, x times negative 3 is negative 3x, 1 times negative 3 is negative 3. So it works. So because everything works here, I'm going to write down the factors as 2x minus 3 times x plus 1. And those are my factors. So that will be all for this question. Now let's go over the next one. Simplify 2 times x squared to the power of 3 times 5x to the power of 2. Now in this type of problem, I need to know the law of exponents. And I'm actually going to apply two different laws here. The first one is the power to a power law that says that if I have an exponent raised to another power, I can multiply them. So that will give me, well, 2 times whatever I have inside this parenthesis is just 2 times x, and then 2 times 3 is 6 times 5x squared. So then I multiply my, I forgot the name of it, the number in front of the variable. It will come back to me later. But I multiply the coefficients. I multiply the coefficients first. 2 times 5 is 10. And x to the power of 6 times x to the power of 2, because I'm multiplying, the multiplication rule of exponents says that if I have exponent with the same base multiplying, this allows me to add them. So that gives me x to the power of 8. And that's it for this problem. Okay? That's it for that. Now we have a different one. It says solve for x, and this looks different on every single problem. Okay, so as I'm solving for x, this is a linear equation. This is another linear equation, but it's called, this is a formula actually because I have two variables. This is a quadratic. I'm going to have to use the the zero product property, and this is another quadratic. I'm gonna have to do the super x box. This is actually the hardest problem here. So this is just solving for x. I'm going to distribute first. That leaves me with 5x minus 3 is equal to 2x plus 8 plus 1. Well, I'm going to combine like terms here. That leaves me with 5x minus 3 is equal to 2x plus 9. And then I want to start moving my x's to the same side and my constants to the same side. It doesn't really matter where I move them. What matters is that I use the correct operations. So because I have a minus 3 here, I'm going to add 3 plus 3. That leaves me with 5x is equal to 2x plus 12 minus 2x minus 2x. I'm going to continue here. 5x minus 2x is 3x. This cancels out, actually equals to 12. And then 3 times x equals 12. Well, the opposite of multiplying is dividing, so I'm going to divide by 3. So x is equal to 4. X is equal to positive 4. Okay. That's it for that. Okay. Next one. Since I'm solving for x, the first thing that I have to move is this positive 4y. So I'm going to subtract 4y from both sides. That leaves me with 2x is equal to negative 16 minus 4y. And then I can divide everything by 2. Remember to simplify if possible. Negative 16 divided by 2 is negative 8. Negative 4 divided by 2 is negative 2y. So that's it. Now on this one, I can use a zero product property. When I have two factors multiplying each other and the result is 0, then that allows me to set each factor equal to 0 and find out what the value of that variable is. So here I have one factor, here's a second factor. So that leaves me with x is equal to 0 for the first one, and x minus 2 is equal to 0. Well, this one is already solved, so I don't have to do anything. And the other one is, well, if I add 2 on both sides, that leaves me with positive 2. And that's it. That's it for this part. The other thing that you can ask yourself is, well, what number can I place here for x that when I multiply this or when I solve it, my answer will be 0? Well, if you put 0 here, 0 times anything gives you 0. And well, ask yourself, how can I make these other parentheses a 0? That is, well, if you subtract 2 minus 2, that gives you 0. 0 times anything is 0. That's pretty much the logic behind it. Okay, with that being said, let me jump into the second to last problem that I'm going to go over on this video. This is another quadratic equation. And because the leading coefficient is not 1, I'm going to have to do the super x box. Okay, so I multiply again 5 times 2. 5 times 2 is 10. And I write down the middle term, the coefficient of the middle term on the bottom. I'm going to set up my box here, that is 5x squared and 2. And now I'm going to find the magical numbers. Well, the magical numbers are 10 and 1. 10 times 1 is 10. 10 plus 1 is 11. I'm going to set them up here, 10x and x. And now I ask myself, what is the greatest common factor between 5 and 1? Well, the answer is 1. How many power of x's do I have in common from an x squared and just one x? And the answer should be x. Then you need to ask yourself, well, what times x gives me 5x squared? The answer for that is 5x. What times x gives me 1x? The answer for that is 1. And then you ask yourself, well, 5x times what? I need to find that number here. 5x times what gives me 10x? And the answer will be positive 2. So now that I found my factors and you can check if this works. I'm going to write them. I'm going to write them equal to 0, and because of the zero product property rule, I'm going to set each of the factors equal to 0 and solve for x. That's to find the value of x. So minus 2, x is equal to negative 2, minus 1, divide by 5, so x is equal to negative 1 over 5. Okay, that's it for this problem. We have one more problem that we have to go over. That is solving system of equations. Okay, so this is what you have to do on this one. First thing that I notice is that I have one variable that is isolated. So I'm going to use that for my advantage, and I'm going to substitute everything that is y for the first y on my first equation. So when I write this down, I get 2x plus y. I'm sorry, it's no longer y. Actually, y is 5x minus 11. So it's 2x plus 5x minus 11. I'm going to put that in a parenthesis, equals to 10. Now let's combine like terms. There's nothing that I have to distribute, so the parentheses go away, and that leaves me with 2x plus 5x minus 11 is equal to 10. Combine like terms, that is 7x minus 11 equals to 10. Move negative 11 to the other side by adding. So that gives you 7x is equal to 21. And now you can divide by 7 on both sides. So x is equal to positive 3. Remember that when you're solving a system of equations, you need to find the value of x and the value of y. If you've only found the value of x, you're halfway through solving the whole problem. Now, in order to find the value of y, I can substitute this value of x into one of the equations. And I'm going to use the second one because y is already isolated. So I'm going to do y is equal to 5 times 2 minus 11. I'm sorry, it's 5 times 3, not times 2. So I'm left with 15 minus 11. That's 4. Now that you've found the value of x and the value of y, do not forget to write them as an ordered pair. That will be 3, 4. And that's the answer for this system. And you can check by plugging in. 2 times 3 is 6, plus 4 is 10, so that works. 5 times 3 is 15, minus 11 is 4, so it works. So that is your final answer.